Hello and welcome to another learning video from TechPA. At this time, we're going to gain deep knowledge of RSA protocol. RSA is an asymmetric encryption algorithm that uses two different keys, one for encryption and one for decryption. The encryption key is public and can be shared with anyone, while the decryption key is private and must be kept secret. The generation of encryption and decryption keys, for example, for entity Bob in RSA, involves the following steps. Bob chooses two large prime numbers, P and Q, and computes their product, N equals PQ. This is called the modulus, and it determines the size of the keys. P and Q are prime means their only factors are 1 and their cells like 3, 5, 7, 11, 13. Bob also computes the Euler-Totient function of N, which is the number of positive integers that are relatively prime to N. This is denoted by hyphen, and it can be calculated as hyphen equals. Bob also chooses a small number, e, that is relatively prime to hyphen n, which means that the greatest common divisor of e and hyphen n is 1. This is called the public exponent, and it is part of the public key. Bob also finds a number, d, that satisfies the equation d is equal e power of minus 1 mod hyphen n. This is called the private exponent, and it is part of the private key. After all of this, Bob can make a private key by n and d and a public key by n and e. We have public and private keys, so we can do encryption and decryption. Encryption is the process of transforming a message, M, into a ciphertext, C, using the public key of the receiver. It involves the following steps. Compute C equals M power E mod n, where M is the message converted into a number, E is the public exponent, and N is the modulus. Decryption is the process of recovering the original message, M, from the ciphertext, C, using the private key of the receiver. It involves the following step. Compute M equals C power of D mod N, where C is the ciphertext, D is the private exponent, and N is the modulus. So let's do some real thing. Imagine Alice wants to send the message TechPA RSA video to Bob. First, Bob should create a public and private key and give the public key to Alice. Bob chooses P17 and Q11, then N equals 187, and computes the Euler-Totient function, which results in 160. Bob chooses a random number, E, that is relatively prime to hyphen n, which means that the greatest common divisor of E and hyphen n is 1. For example, hyphen n is 160, so a possible choice for E could be 7. Bob finds a number, D, that satisfies the equation D equals E power of minus 1 mod hyphen n. For example, if E is 7 and hyphen n is 160, then D is 23 is a possible choice. The public key is composed of N and E, and the private key is composed of N and D. So, the public key is 187 and 7 and the private key is 187 and 23. Bob gives the public key to Alice and says to use ASCII for converting your message to numbers. Alice then should change the phrase TechPA RSA video into a number, M, that is smaller than the modulus. One way to do this is to use the ASCII code of each character and concatenate them into a large number. For example, the ASCII code of T is 84, so Alice can represent it as 084. The code of E is 101, so Alice can represent it as 101. And so on. The phrase TechPA RSA video can be represented as M. Alice needs to encrypt the number M using the public key of Bob. The encryption formula is this. Using the example values of E7 and N187, Alice can encrypt M as follows. The result is C173. Finally, Alice sends C, which is the number 173 to Bob. This is just a number for other people and nobody can interpret it. Bob needs to decrypt the number, C, using his private key. The decryption formula is M equals C power of D mod N. Using the example values of D23 and N187, Bob can decrypt C as follows. This is the same number that Alice started with, which means that the decryption worked correctly. To get back the original phrase, Bob needs to reverse the conversion process. Bob can split the number into groups of 3 digits and look up the corresponding ASCII character for each group. For example, 084 is the ASCII code of T, 101 is the ASCII code of E, and so on. The phrase TECHPA RSA video can be recovered. I hope you find this video interesting. Please like and subscribe for more.